All right, so let's continue on from where we were last time. And we were looking at this first exercise in Lab 5. Oh, and by the way, I put back the date of our next exam by 2 days, I think, something like that. Okay, so it'll be a week from today. The exam is a week from today.
Thank you.
And it covers this material, all right, on classes. So we needed to develop this number class, and I gave you this test code to use, and this test code needs to run. And then there's a UML class diagram and so on. So we left it like that last time. Let's look at what's in this number class. Here's the header file. And this is the include guard, so that the include file doesn't end up being included more than once. And then we have this diagram that has 3 sections. It's a unified modeling language diagram, a type of unified modeling language diagram called a class diagram. It just gives an overview of the class. This is the class name. These are the member variables. The minus sign means the member variable n is private. And there's a colon followed by the data type. So n is an integer. So this number class lets you create instances that, that basically contain an integer as to represent its state. So if you have 2 different number instances, one represents a 7, the other represents a 9, right? N will be 7 in one, n will be 9 in the other. So we can have more than one variable. I mean, normally we have more than one, so this is a trivial example. And then the third section is a list of functions. These don't all have to be public. Some can be private. So we just indicate that like this in the diagram. But in our case, all of our functions are public. This first function is called a constructor. It's what's run when the system creates an instance of your data type. This constructor takes a single argument, an integer n. Of course, the value that's passed into the constructor is copied to this member variable n here. And that's the reason I used the same symbol for both of them. The argument is n, and the member variable is n. So it's a pretty straightforward copy. The n that's passed into the constructor, that value is copied to the member variable n. But they represent 2 different n's in code, right? They have different scopes. It's the same name, but with different scopes. So we use this arrow to indicate which of those n's is a member variable. And we'll look at that again in a minute. There's a function is prime and is divisible by. These are 2 functions that you can call on instances of the number class. Is prime, this function, when it's invoked, it resolves to a Boolean value, true or false. So if the number that the instance represents is prime, then when we invoke is prime, it should resolve to true. Otherwise, it resolves to false. Is divisible by is another function, but this function is different than the is prime function because it takes an argument. It takes another integer. So what we want to do is compare our integer n, the integer that we're representing, that this instance represents, with the integer that's being passed in, k. How do you compare to k? And in particular, are you divisible by k? So we return true if the number we're representing is divisible by the value passed into the function. This ends the multi-line comment here. So that's our documentation section. So here's the class declaration. This is similar, like in your code, you might do something like this. You might say int j. That declares, oh no, it's not the same actually. I'm going to take that back. I'm not going to go into that.
Professor, I believe you wanted to make sure to explain constant the end of last period.
Yeah, let me do that right now. That's good. Thank you. So here's the class declaration. You need to remember, not for the exam, but for when you write code, you need to remember that you have a semicolon at the end of that. And these are the opening and closing braces that follow this, the syntax here, class number. So class followed by the name of the data type. And notice I'm using an uppercase N, so that's a convention. I could use a lowercase n, and that's all right, except it kind of goes against the common convention that programmers follow. So we'll follow the common convention, which is to use uppercase on class names. In fact, these class names follow a naming convention normally called upper camel case. So if this were to be a big number, the class name would be big number, like that. So we'd have, this is called camel case. So this is an uppercase letter. Each word in the name is capitalized. Here's the constructor. It has to have the same name as the class. You can have multiple constructors. We could have another constructor that takes another value, or doesn't take any value. In this case, it would be more meaningful to have this kind of a constructor. Here we're declaring these things. You could also define it right inside the include file. Something like that. That's okay. But I'm showing you an organization in which the definition of functions appear in an implementation file that ends with the extension CPP. So this is also possible. And this would make sense. This is creating a number instance, but giving the value that it represents some initial state, 0, right? Or maybe you could do 1. But so I think 0 would be kind of the common initial state. Now there's another way to define this constructor. You can also use what's called an initialization list, which you have the name of the variable, followed by parentheses, followed by the value that it's set to. Actually, this variable is an int, so when the int is allocated, assign it a 0 or assign it a 2, whatever it is you want. That's another form of initialization. You could also have code in here as well. You know, you could also run other code inside the constructor. Just to show you all the possibilities. But we don't need that in our problem. I'll just comment that out. And then we have is prime and is divisible by. These are declared, but they're not implemented. And last time I talked about this const keyword. And what const is, it's a promise to the compiler, or it's a restriction that you're assuming onto your function, that the function, when it runs, it will not change the state of the instance. So when you call is prime, it won't change n, because n is the only thing that could change, because the state of number instances are completely determined by the value of n here. So const means we're not going to change n or any other possible number variables that we might add later on. And this is good, because what we're doing here is we're narrowing the scope of what the function is allowed to do. And in general, it's good practice to narrow the scope of things as much as possible. It makes it easier to understand their purpose in the program. If the code is written too generally, it's hard to grasp its role in the program. So if it has a very narrow scope, that you know you only have to look into a smaller amount of concerns or areas of your code base to comprehend its use in the program. So if we declare is prime const, we know that, oh, well, is prime does not change any number of instances. Well, declaring is prime const here, by the way, is divisible by k is also a const function, or can be declared as a const function, because that, although we pass in a k, we don't use it to modify n. We just use it to compare to n. Now this should not compile because I declared in the declaration of the class, I declare these two functions as const. But in the definition file, I'm missing that declaration. So here, this is prime is described as being non-const, as without const. So this will give a compiler error. Oh. Is prime does not match any declaration in number. See? So this is here the compiler is complaining about number.cpp. Says, hey, you're declaring a function is prime, but we don't see that in the declaration of number. You know, the function that you're defining does not appear in the class declaration. And the problem is that it differs by this attribute here, that we have not yet defined this as const. Let's add that restriction and then run it. Now it compiles, no problem. Let's suppose it is prime did modify the number class. Let's see how that would work. Yeah, we'll do it like this. So if we did something like n equals n plus 9. So now is prime is actually modifying a member variable. So what happens? What should happen based on what I've said? What is the compiler going to do? The compiler is going to say, you lied. You said you were constant. The function was constant, but you're modifying n. Oh, that's not correct. It says read only. Oh, that's how they report it. Read only variable is not assignable. I haven't seen it reported that way before. Read only variable is not assignable. Got that? So when we declare the function const, then n is a read-only becomes a read-only variable. We're assigning to something that's not assignable. So that's a compilation error. So what we could do is then, of course, we could remove the const. Let's say we don't want n to be read-only anymore. Now we have another problem. Oh, we also have to take it out here. Now we got it. Of course, it won't run correctly, right? So the test code will fail because we have we're modifying n, so we're getting some crazy value now. So we'll get failures there. So let's return this back to its original state. Compile, run. There we go. So that is the.
So we would only have to put the const on on the number dot H, but not in the number dot CPP?
No, you have to put them in both. They have to be synchronized.
Oh, okay.
Either omit them from both or add them to both.
Okay.
All right, let's go to the next one. Write a program that prompts the user to enter a number larger than 2. The program should use the number class you developed in exercise 1 to determine the prime numbers between 2 and the number entered and display them in the console window. So we did this problem already, but now we want to see how to do it using this number class. Now, we already have this ex1.cpp. That's our main. That's our has the main function in it. Actually has test code. It tests this number class. Now we have a tested number class. Now we could use it. So let's create another program. Put it in ex1.cpp. Another implementation of main. So we don't need all this stuff. And we'll do something like enter a number greater than 1. Just leave it like that. So we're including this number class. Let's just going to get that to compile. Oops. I'll use this. Notice I have to have all the implementation files on the command line here when we're running the compiler. So number.cpp and ex2.cpp. All right. So once we have this value k, what we'll do is, and this is what we did last time, we run through all the values starting at 2, not 0, 2, and going up to and including k. And if I is prime, then print I. That's what we want to do. So we look at all the numbers from 2 to k. Did I get that right? Wait a minute. Yeah, that's right. Determine the prime numbers between 2 and the number entered, and then print those. So we're declaring this variable I, and it's ranging from 2 up to k. And k is the value entered by the user. And let's go ahead and do this. So we'll create an instance. I'll call it n, number n, and pass in I. So we'll create an instance of this number class. And we'll use that isPrime function. If n dot is prime, then we'll see out I. So 7, 19. So that's that. It's not a great example, to tell you the truth, but it's not too bad. We could also do something like this, like after we create the n, let's use n in this expression. Or we could do something like n dot, say, get value, or get int. This is called a getter function. Let's try this. Let's, just to show you how that works. Maybe we want the ability to get the value that n represents, to get that value as an integer. The other way to do it is to, or another way to do it, is to define the output operator, to add a definition to define this output operator for when it takes two arguments, an output stream and an instance of the number class. It's kind of an advanced topic, so I'm not going to show this one. This is an important topic. This is called an accessor function, and it's used to access the data directly that's hidden inside of the instance. And this is very common. You see this a lot in code, something like this. And by the way, this example is, it's a kind of a silly example. It's too small. You wouldn't define a number class to solve this problem, right? The solution that we had in the last lab is probably sufficient. You wouldn't actually go to the trouble of defining this number class to create this a solution to this problem, but we're doing it just to learn about classes. So it's a bit of an artificial example. All right, so the compiler will refuse that because this function getInt is not defined. So let's go ahead and define that. And we'll modify the UML class diagram. So getInt takes no arguments, but it returns an integer. And then let's put it down here. Well, getInt is also const because it doesn't modify the number. So let's put in getInt here. So getInt returns an integer, and getInt is inside the number class. So we prefix the name of the function with the class name. We defined it as const. We need to remember that. And we simply return the member variable n, its current state. Let's see. We don't actually need to use this n. Some programmers will use this just as an annotation, as a documentation, a means of documenting that n is a member variable. But there's no collision with another n that's in the same scope right now, so we could just write it like that. But here we have to use this arrow n because there's a variable n that has a more narrow scope, which is covering n, that's the member variable n. So we need to tell the compiler that this n here, the left-hand side of this assignment operator, is the member variable n. So that's up to you. If you like this, which some people do, you can just put that in there. Of course, you might want to do it to all of these, including this one and this one. See, I think that it gets to be a little bit, it adds too much to the code. And normally, you wouldn't define another n in a function. it just typically happens only in the constructor, typically. Not always, but typically. And so this is, I think for the sake of brevity in your code, it's that this is the pattern that I follow when I write code. And some languages require you to annotate these ends as member variables. I think Python does that, like self.n, I think you have to do it like that. So on. All right, so let's see if we got that. Yeah, it's good. So now it's now we've implemented this getInt function. Works nicely, and that's called an accessor. There's also let me show you also an example of a setter. This is called a getter and a setter. This sets a value of a variable hidden inside n. I'm sorry, this gets a variable that's hidden inside n. Let's set a variable. So let's create an instance, an empty instance of n here. And I'll put it outside the loop so we don't have to run it over and over again. When the user inputs a value, that we'll set it here. Oh, sorry, not in the user. In our loop. So we want n to represent different values. So we'll define a setter function. And so we don't run the constructor each time. We just keep a single instance allocated and just modify the value that it represents with our setter function.
When would you want to use that?
Huh?
When would you want to use that?
Well, here's an example right here. So we're
It doesn't seem like the function is necessarily complicated enough to have, that you don't have to use it for this, but when are cases when you would have to use it?
I think you can always get around it. I think you don't have to do it this way in 100% of the time.
Oh.
Yeah, it's only do it this way when it improves the readability of your code.
Okay.
And like I said, this is an artificial example. It's hard for me to motivate these choices. I'm showing you all the alternatives that you have when you write code. And this is a kind of a bogus example here. It's small and simple, so it's easy to present. And you'll see this. This is very typical. I'm showing you very typical things. I don't know if you would have, maybe more typical than this, you would have, the name isn't too bad, but you might see value. Whoops, sorry. You might see a better name here, value, get value. Although you lose the idea that it's an integer rather than sort of a floating point value or something very general. Maybe I'll put that back to int.
And all of these will give you a list of integers from 2 to n?
Yeah, that are prime.
No, yeah,
That are prime. Or 2 to k, where k is the value entered by the user. And n is just a wrapper around I. Actually, this is called a wrapper class. It takes a primitive data type, an integer, and just wraps it with a class. And the purpose of that is to add functions to it that are specific to integers. So you see languages like Java, for instance. They have all the different primitive data types have wrapper classes. So you would see something like in Java, this wouldn't be called number, it's called integer. And it's provided, you don't implement it, it's provided to you as part of their API. All right, let's do this set int. We need to implement set int. It looks like get int, so I'll copy that. And setting a value is a void function, but it takes it has to take an argument. So this is an example that outside of a constructor where you need to distinguish between a member variable and a variable passed in as an argument. And it's handy to have to use this n like this because it's good documentation. We're passing in the value and it's simply meant to be copied over into the n that we're hiding. I'm going to leave a bug in here and let you try to spot that for me. Anybody spot the bug? All right, this is a contest. Huh?
You can't use this n, so that ends.
No, you can. Yeah, this is good. Because we're passing in n here, and we need to distinguish between the n being passed in and the member variable n. Anybody see the bug?
Constant.
Why is that?
Because the numbers change and changes.
Exactly. Very good. Got it. You got it. We can't declare this function as const because we're modifying the member variable n. And is well, according to the comment, the error message that the compiler gave us, n is a read only in this context. So let's take out that const. Very good on that one. So set int. Let's add that one. If the function is void, we could do colon void or just omit it. I'm just going to omit void. This is set int. That's not const. All right, let's see if that runs. So no matching constructor for initialization of number. See here, I'm trying to invoke a version of the constructor that takes no arguments, but we didn't define that. We did at the beginning of the class, but we didn't. We commented it out right here. So now we need that. There's a version of the constructor that takes no arguments, and I think 2 is not a great value. And let's do this. This is the no arg constructor for number. I just put, maybe we're trying to debug the code or trying to understand how control flows through the code, and we've got some of these output operations going on. But to use, I think we need to use this header file. Whoops. I think this needs to be in the std namespace. I didn't read it, I just saw there was an error there. Quickly thought that might be it. That was it. That looks good. No arg constructor. It's hard to read the output. Let's put a new line in there. What? Anybody know the problem? I didn't do using namespace std, so I have to label each use of a name from that namespace with std as a prefix.
I imported it rather than actually creating it. Was creating different.
So there's the no arc constructor for number. But you know, this shows you how to do it, just so I show you how to do it. It's a little inconsistent. It's not bad. I guess we can leave it the way it is. We don't need that. It's a bit inconsistent, so you know, maybe a better design would be to declare this here and add the definition in the implementation file. This is to keep consistency. This dot n is 0. Of course, we don't need this because there's no naming collision going on in that function, so we can do it like that. So that's it.
Can I take a quick picture?
Yeah, just I'm flying around, aren't I?
Yeah.
This is, I am videotaping this, so you know, you can get it from that. But which one did you want to take a look at? Anyway, it's on the tape if you want to see it, or the video.
So we're being recorded?
Yeah.
Hello.
I'm sorry, there we go, say hello to the world. That's, last time, sorry, I don't know what I did, but I failed to record the last lecture. So I'm reviewing a lot of details quickly, so you have a record of them that you can reference. All right. Are we ready to go to the next example? An egg carton class. All right, let's design another data type called egg carton that's used to represent egg cartons. Remember, a class is like a pattern. It's a, you know, there's one class egg carton, but out of that one class you create many objects, or many instances. And each instance that we create will represent perhaps some physical egg carton that's say in the inventory of a grocery store, something like that. Of course, what we're going to create here may be a little silly, but just, you know, it's another one of those examples, simplified examples to illustrate different things in a simple way. So provide an implementation of the egg carton class, it should be carton, described below, develop test code to test your implementation. So here's the UML diagram. You know, we've got that as a starting point. And here's a description of how things work. Instances of the class represent egg cartons that hold up to 12 eggs. The class provides functions to add white and brown eggs. All of the functions that modify the number of eggs in the carton return false if the operation cannot be done exactly as requested. And I'll restate that later when we get to that point in the problem. What is this? Exercise. Develop test code to test your implementation. So here I'm giving you the UML class diagram and I'm saying, you know, implement these functions according to this description down here. And write your own test code. So let's go ahead and try to do this. Let's see, how do we do that? It's a little different than this number class problem. I gave you the test code and asked you to write down the UML class diagram and implement the functions. Here we need to implement the functions and implement the test code. All right, let's do this. All right, here's the test code. Well, it's going to be not number, but it will be egg carton. So we're going to test this egg carton. Let's create the header file. I'll use Pragma once, it's a lot easier to type. And we have the class name. And I'll let the compiler generate a no argument constructor that does nothing. And I'll go a little farther here. We'll create an instance of the egg carton class. Like that. We have no egg carton.cpp yet, so I won't put that on the line. So there we got it. We have sort of the shell of our program. See, that's how I think you should start when you solve this problem in the lab.
If you give me a second, I can do it that right now.
Yeah, do it if you can. We have a half an hour to do this. You see, I'm doing it step by step. This is just, I'm creating, just to get the basic shell of the program running. Then I fill in the details.
Professor, out of curiosity,
Yeah.
I've only seen that, and I don't include it, the int argument, character, pointer argument.
Yeah.
What are those for specifically?
That's for the entering things on the command line. For instance, I'll show you. This argv, that's a vector, and argv of 0 is always defined, and it's the name of the file that you entered in to run the program. Well, let's see what that looks like. Well, let me put a new line at the end of that. So this should print a.out. Oh, dot/a.out. Now, the next argument is the first argument that's entered on the command line. So if I enter in the string hi on the command line, it'll print hi. So that's how you access the command line. This gives you, this is the number of arguments on the command line, and this is the an array of string pointers that you use to get at the strings that appear on the command line. Keeping in mind that the first item in the array is the name of the file that was used to run the program.
Cool, thank you.
All right. So let's go and implement this class. So there are two member variables, brown eggs and white eggs.
They're private?
Yeah, those are private. And that would be the normal choice.
So then are we still calling this member.h or egg?
No, it's egg carton.h, egg carton. So we're going to have a constructor, I'm just going to guess here. Well, I wrote the problem, so I mean, normally the constructor takes values that are directly copied into the member variables or used to generate values for the member variables. So the purpose of the constructor is to initialize instances of a class. So it should take, wait a minute, the wrong place here. There it is. See, there it is right there. The arguments of the constructor are those values that we use to initialize class instances. So that's brown eggs. We'll use the same format that we did last time, which is the same organization, which is to use a separate implementation file for the function definitions. So that's egg carton. Let's do it here. Where am I? Oh, I see, that's the main. Okay.
I lost it.
So well, let's include the egg carton header file. Oops, need that sharp symbol.
What did you name this .cpp file?
Eggcarton.cpp. Take a look. I didn't save it yet. Let me see. See, the names are, that's the typical naming convention. The exact characters that you use for the class are used in the file name. So eggcarton.cpp, eggcarton.h. And you'll see this in other languages. In fact, in Java, it's required to have the matching names. File names have to match a class name. So they put that restriction on you. So this egg carton, let's create an egg carton that has, 4 brown eggs and 3 white eggs. Okay. Now this won't run now because we didn't define this. We're in the process of defining that constructor. So here it is.
That's your head file. Is this your head file? That's your head file.
So there it is. Once again, the purpose of the constructor is to initialize instances of the class. Instances of the class, their state is completely defined by their member variables. In this case, brown eggs and white eggs. So the constructor needs to set brown eggs and white eggs to particular values that make sense. And of course, those are the 2 arguments. We're going to use the 2 arguments passed into the constructor for that.
The default constructor would have no arguments in it, right?
Yeah, some people use the word default constructor, and I avoid using that terminology. But yeah, that's right. The default constructor would be the constructor that the compiler automatically defines for you when you don't define any constructor at all. If you define any constructor at all, that default constructor or no argument constructor is not automatically defined. So we got that working. let's implement the get total eggs. I think that's easier to do next. So we'll do the test code first.
What's 3, 4? What is the 3, 4?
4 is the number of brown eggs that the carton will hold.
White.
3 is the number of white eggs. So we're telling the constructor, hey, when you build this, representation of an egg carton, have it contain 4 brown eggs and 3 white eggs.
Is that the limitations of the actual class or the object you're creating, that it can only have up to 4 eggs and only up to 3, or is it just that that's how you started off?
No, it's just random. We could have made that 5. It doesn't matter. But it can't be more than 12. I can't use 13 here because that would be 17 eggs. But stated in the problem statement, the cartons hold exactly 12 eggs. So we can have less than 12, and we can have 12, or we can have 0, but we can't have more than 12. We can't have less than 0. And in our code, we're not going to write code that checks those boundaries. We're not going to add code that checks, we're going to add some code that checks a violation of that constraint, but a lot of that we're not going to check. For instance, in the constructor, we're not going to check that the 2 values passed in are less than 12 when they're summed together. And we could do that. It just makes the problem a lot longer, and I'm trying to keep it simple so that you can master this before you move on to more complicated programs. All right, so it's get total eggs, was that it? Get total eggs. That's an accessor, or getter method, they call it a getter method. And this should be 7, right? So if we print that, we should print 7. Let's see if that works. Oh, we didn't define it. Yes, thank you. So get total eggs. That returns an int. Get total eggs. Is that a const or not a const?
No.
Not a const?
It can change.
Does get total eggs modify the state of the egg carton?
No.
No, so it's const. So get total eggs returns an int. So what's that? Did I add it to the header file? I did, and the implementation is there, so I think it should work. See the 7? Well, we run it 7. So when we call get total eggs, the value is sent into the standard output stream. That's just so that we can see it. But actually what you need to do is create test code, just like the test code for problem 1. And so we're not going to, the test code this would be like the test code, we need to visually inspect that the value is what it should be, right? That's error prone, and it's difficult, it's time consuming to do over and over again as you're developing or modifying the program. So what we're going to do is write our test code so that it's automated, so it's part of the program itself. So we're going to use the assert header, which is up here. We can get the assert macro. And let's put that in there. So assert carton.getTotalEggs equals 7. So that's how the test code is going to look. All tests pass. Once again, you know, if we did something wrong, well, I'll do it this way. There could be a bug in the test code, or there could be a bug in our program. So you have to watch out for both sources of error. Let's assume that the test code is good, that the bug is in the program. And instead of brown eggs plus white eggs, we return brown eggs plus brown eggs by mistake. Oops. So here we have a bug in our implementation of the egg carton class. So now when we run it, we got a failed assertion. Oh, get total eggs is not equal 7, but pretty sure the test code is right. So there must be a bug in the get total eggs function. We examine that and we see that indeed there's a mistake in there. It should be white eggs, not brown eggs. There it is. All right, there's our test code so far. So we've defined the constructor and this get total eggs function, and have tested get total eggs. Let's implement add brown eggs. And add brown eggs takes an integer number of eggs to add. Now, this is the function where we need to test to see if the calling code is passing in a bad number. So if the total eggs will exceed 12, then we want to return false. You see this add brown eggs is a bool. It returns false if it's not possible to add those n eggs. And it returns true if it was okay to add n brown eggs, and it did it. And returns if we can't add n brown eggs because it exceeds the limit of 12, then we don't add any eggs at all, and we return false. And I explained to you what is in here. Basically, it's stated in here. So once again, this is add brown egg. So let's write the test code first. Let's add 2 brown eggs. And then when we call get total eggs, after adding 2 brown eggs, our total eggs should return 9. See that? So we'll use that for testing. So it's a void, so it's add brown eggs, and it takes, say n, I'll pass in an n there. Did I give it a name? Yeah, I used n. Is this const or not const?
Non-const.
Non-const, exactly, because we're modifying the state of the object. We're modifying one of its member variables. So this is add brown eggs. I totally messed that up. There we go. Oh, I'm sorry, this is not void. This should be bool. I'm sorry about that. That's let's put a stub in there. Let's just say we figured it out that that we added the n, you know. Let's just return true. Once again, that's a stub. And let's adjust this declaration here. This is a bool. It returns true or false, whether it was possible to add or not add n brown eggs. Now the test code is going to change a little bit. This add brown eggs, this should return true. So let's put that inside of an assert statement. Add brown eggs should return true. You know, it's optional. We don't have to say equal true, just use the value itself in the assert function. But a lot of people think that this is more readable, so I'll put it like that. And then we have 9 total eggs at this point, so this should work. Let's see if that's the case. Oh no, this will fail, right?
Yeah, if you're not adding anything, you just
We didn't add anything.
return true.
Let's see that it fails there. Let's test our test code. Oops, what am I doing? There we go. So there it is, 9. So we didn't add any eggs. There we go. Good. Let's do it. Let's do the simple solution first, which is to take our brown eggs and add n to it. We're almost over. We're almost done. Because I'm not going to do get white eggs because it's the same as get brown eggs. What you need to do, get white eggs, or add white eggs rather. All right, so now this works, but our test code is not very good. We're only testing, you know, a positive value returned from add brown eggs. Let's try a value that should return false. Give me an example. What's a good number that I can pass in that would have to fail here? 3? No. 4. 4 should fail, right? That's 13 eggs. Got 9 eggs and I add 4 more eggs. That gives me 13 eggs. So that should return false. And the total number of eggs should remain the same at 9. I run the test code. Is it going to fail or succeed? Yeah, because we didn't handle that case in our implementation. Now I want to tell you that the procedure I'm using now is called a test first software development strategy, a test first approach. And this is kind of it's a methodology that's widely used, or I don't know, it's widely acknowledged as effective and used by many programmers and employers. So it's a current sort of the procedure I'm showing you is what I'm saying is kind of represents current practice in the industry. All right, let's see here. So basically, the procedure is I write the test code first, watch it fail, and then provide your implementation, and then run the test code again and watch it succeed, or fix until it does succeed. So that's what we've done. We've added the test code. We put in a stub. This is, well, returning true is our first stub. The second iteration of the function, we just did the simple thing of adding in n. We didn't check for limits. We saw that that worked. And now we added test code to break what we know is breakable. But we write the test code first, we run it and see that it fails. And now we do the implementation. That's the process. So this is the last thing we need to do today. So hang in there. So if if brown eggs plus white eggs plus n is greater than 12, then n is too big. Let's return false. And I'll write it like this. Else, n is okay, we'll add it in there and return true. Does that look okay? Let's see. This is the payoff now. It should just run. If it just runs, the class is dismissed. Okay, and we've done it. We've finished our job as software developers. And if it fails, we've got to go and debug. All tests pass. We're done. All right, you need to also implement the set or add white eggs, but everything else is pretty much done in the same way. All right, that's it. I'll see you on Monday. The quiz will be a week from today, or the exam a week from today, covering this material.